A very good morning to all of you. So today we'll try to understand some numericals on chopper. So as you know that the DC motor will be acting as a prime mover in the DC drive, and to provide a voltage to a DC motor we need to have the control converters and the choppers which will be giving the DC voltage to a DC motor, and accordingly torque and speed are going to generate. So before starting with the numericals of a chopper, first we need to understand some um, formulas, that is a duty ratio of a chopper. Now what is a duty ratio? Duty ratio, because chopper basically is a simple semiconductor switch. So depending upon the duty cycle of the switch, the DC voltage will be can be made variable. So basically chopper is going to convert a fixed voltage into a variable voltage. So you can see that this is the fixed voltage we are saying, that is the VA, and this is a variable voltage and it depends upon the duty ratio. So this is also the VA3. So basically, if you want to take the duty ratio of a chopper, so that will be delta will be equals to T1 upon T, or you can say it is the variable voltage upon the fixed voltage. So now the other things are same. That is, if you that is the back EMF is directly proportional to the flux and the speed. The flux is maintained constant as you are having a separately excited DC motor where field and the armature winding are separated. Field winding is separately excited and armature winding is separately excited. So you can say that the flux is constant. So it means that the back EMF is directly proportional to the speed. So now this is for the motoring operation. Again, you know that the motoring operation will be VA will be equals to E plus IA into RA. So basically this armature voltage is providing the power to the DC motor, and accordingly there will be a power dissipation in the resistance and some power gets stored inside the inductor. But for the DC voltage equation we have not taken into account the inductor voltage, because the average value of the inductor voltage is always equals to 0. So we are having this equation, that is VA will be equals to E plus IA into RA. This is for motoring. And if you need to break the motor, or you can say the stop the motor, we need to provide the we need to supply that energy to the power source. So in that case the E will be more predominant as compared to VA. So E will be equals to V plus IA into RA, or you can say V will be equals to E minus IA into RA. So you will have to keep these three things in your mind while solving the problems for the chopper. So now we'll get back to our question, that is numerical, which we wanted to solve today. So this is the on chopper. So now there are two questions. These two questions are very much similar. If we solve this first question, you will be able to solve the next question. So a 230 volt 960 rpm 200 ampere separately excited DC motor has an armature resistance of 0.02 ohms. So armature resistance is properly given. Then these are the rated values. You can see VA will be equals to 230 volt. Then you are having the rated speed, that is the rotor speed, or you can say the motor speed. Then the 200 ampere, this is the rated current for a rated torque. So basically, like in the previous two videos we were discussing about the rated torque and half the rated torque. So in that case, suppose if the rated torque is there, then you will have to keep the same current. But suppose in the question, if they ask the half of the rated torque, then you will have to divide the current by 2. Or if they ask twice the rated torque, then you will have to multiply the current by 2. Fine. So this is the simple way it is given. The source has a voltage of 230 volt. Now this you can see that the source is also having the fixed voltage. Assume the continuous conduction. Um, assume this is the continuous conduction value, then find. So these are the low speed drive. Basically when you are going to, when you are saying that continuous conduction is happening, it means that we are dealing with the low speed drives. Find the duty ratio of a chopper for motoring operation and rated torque and 350 rpm. So 350 rpm is the speed. So it means that you will have to calculate the E2. Now before starting with all this, first we need to calculate the back EMF for the rated speed. Fine, because we did the same thing in the previous two videos. So this one is a VA, that is 230 volt. Then basically this is N1, and this is the IA. So how to calculate the value? uh, just a minute. So VA will be equals to E plus IA into RA. So now uh, we have to calculate E1 will be is equals to V minus IA1 into RA. So everything is given, so you can easily calculate the value. So this is 230 volt. This is 230 volt minus IA1 is 200 into RA. So RA is 0.02. So if you just calculate the things, then what is the value? Let me check my answer. Just a minute, hold on for a value motoring operation. Okay, so what is the value? I think it is 220 minus on type chopper is there. Mm, right, 230 minus. So this is around 226 volt we are having. Fine. That is 4, 226 volt we are having. So E1 will be equals to 226 volt. Now what is the next step? You can see that the duty ratio will have to calculate. So because the speed has changed, it means that the back EMF has changed, but the current is maintained constant, sir. So this is the again E2 by then E2 is proportional to N. So E2 by E1 is equals to N2 by N1. So E2 will be equals to N2 by N1 into E1. Now what is N2? N2 is 350 RPM. 350 RPM. So just put down the value. What is N1? It is 960 RPM. So E1 just calculated 226. So after solving this, I think what is the value? It is 82.39. So basically this is the electrical equivalent for 350 rpm. What is the electrical equivalent which is going to appear on the armature of a DC motor? So E1 calculated. Now the now I'm writing here, please have a look. I am then VA2 will be equals to E plus IA2 into RA. IA2 will be IA only because the rated torque is there. This is E2, then 82.39 plus this is 200.0.02, this will 0.02. So 86.39, this is the voltage value. Now what is the duty ratio? Delta is equals to VA2 upon VA. So that will be equals to, what is the VA2? Just calculate 86.39, and what is the VA? So VA is 230 volt. So this is the simple one. So 230 volt delta will be is equals to 0.375. This is the delta which is required if you want to operate your motor at 350 rpm, and that too in the motoring operation. Now for the braking operation, again everything is same. You can see that the motoring speed is 350 rpm, and you want to achieve the same speed in the braking operation. The only thing which you need to change is the what you can say the equation, because in the braking one the E is the more predominant. So E2 minus A2 into RA, this will be minus, this will be minus. So I think the value which you are going to get, let me write it. That is 78 point. I'm doing this for braking operation. Please take a note. I'm doing this for the braking operation. So delta will be equal to, now this is VA3 na VA3 after, because Otherwise, the people will make the commit the mistake. VA3 will be equals to E3 minus IA3 into IA3 into RA. Okay, RA. Now this one is delta will be equals to VA3 upon VA 78.39 upon VA means 230 volt. According delta will be equals to 0.34. So in this way you can calculate the delta for both the motoring and the braking operations. Now the next part is if a maximum duty ratio of a chopper is limited to 0.995 and maximum permissible motor current is twice the rated. Now you can see here what has been done, and the maximum duty ratio is mentioned here, that is 0.9. You cannot make the duty ratio as 1, because in that case your switch might get damaged, which means what, chopper might get damaged. So I'm rubbing all this. So delta max is given, I think. Okay, so just a minute, need to rub this. So delta max will be equals to 0.95 and maximum permissible motor current is twice the rated. So the IA value will be equals to what? IA will be equals to 200 into double, what you can say, because that's twice the rated motor, so 400 ampere is the value. So now calculate the maximum permissible motor speed obtainable without field weakening and power fed to the source. So again, what you have to do, delta is given to you, delta is given to, and you need to calculate, and you have to calculate the speed. So delta max will be equals to what we can write, this is okay, va4 upon va. So delta max, it is 0.95, so va4 upon va. Now va4 will be equals to what, 0.95 into 230, right? Because va, this is the va, no, that is the rated terminal voltage. So VA4 will be equals to how much? That is 218.5. Now, so after doing all this, what has been asked, that calculate the maximum permissible motor speed obtainable without field weakening, right? Just a minute. So now, for speed you will have to calculate the value of E. So how to calculate the value of E, maximum permissible rotor speed without field weakening. So this is the E will be equals to VA4 plus RA4 into RA. So what is the value of VA4? That is 218.5. Then this is 400 into what? This is 0.02. It's given in the problem. So now if you evaluate the value of this, it is 226.5 volt. This is a braking operation I am assuming. I am assuming braking operation. Okay, that's why actually I have taken this as plus only. Fine, because I have assumed the braking operation. Okay. This is the value of E. I think it is E4. Then next thing is to calculate the value of speed. Now again, so E4 is known to you, so E is proportional to N. So E4 upon E1 is equals to N4 upon N1. So you will have to calculate the value of N4. So E4 upon E1 into N1. So E4 means 226.5. E1 means E1 just calculated from here in the previous, right, the starting value which we have calculated 226 into this is 960. This is 960. So what is the value? This is 962 RPM. This is 962 RPM is the maximum speed which can be attained. Now, power fed to the source. Now, how to calculate the power fed? Power means what? P will be equals to V into I. So, this V means what? VA3, and this is IA3. So, VA3 will be equals to how much is the value? 200. What is the value of VA? Right. VA from here we have calculated 218.5 into 400. So doing all this, that is 87.4 kilowatt. This is simple. That is P will be, because there is no power factor attached with this. So this is the third bit. Now, if motor field is also controlled in the part 3, calculate the field current as a function of its rated value for a speed of 1200 rpm. Field current is also controlled in part 3. So now here the field current is also controlled, and you will have to calculate the field current as a function of its rated value for a speed of 1200 rpm. I think this question, I'll give this sub question as a homework. This is very simple. So if you are able to do this, then you will be able to easily solve this fourth bit I'm saying. Fine. So I think in this way you can do this.